Okay, so here we are again. Just a quick thing on scatter plots. These scatter plots are easy. So if you'll look up there, and I'll do a quick scatter. You go to scatter dot on the graphs, and we're going to scatter plot. We want to do women legislators. All right, that's our y-axis. As I've noted on many of y'all's homework, that's where you put your dependent variable. X-axis, this is your independent variable, which in this case we're going to do college degree. What is it, percent? Percent college degree? I don't know, I forgot.
College.
Oh, that's just college, okay. And we just do it, looks like that. It's going to come up in just a second. There it is. And you can double click in here and bring up this. And you can fit a line, I think it's under elements. Yeah, fit line at total. And linear. Okay. There it is. And it reports the, there, it has the R squared up there for it, and I think sometimes your program will fit this line automatically. I've seen it both ways, so that's how you do it. Interesting, this says R squared of 0.336, and I just looked in your textbook and it was supposed to be 0.392. So, you know why? Because I chose the wrong one. I chose 2007, not 2010. So, I'm sure if I did it, chose the right variable, it would have been right. Okay. Now, multiple regression. This is where we'll end with the today's thing here. We are going to predict motor or fatalities, motor vehicle fatalities. I go to states, and we could imagine that, here, focus on me for a second, that motor vehicle fatalities are a function of two separate things. How many young people there are in the state? Young people don't drive as well as older people are. Older people do, they don't have as much experience driving. And secondly is density of the state. So a real densely populated state, I think people are more likely to ride bikes or be on mass transit, subways and buses and things like that. They're going to drive shorter distances also than people say in Montana or Wyoming. They got long to travel. This is very low density states. They have to travel a long way and they go very fast. And so if they were to get in a wreck, you know, if you're going very fast, your chances of living are decreased, and so they are more likely to have higher motor vehicle fatality rates. So let's see. I'm skipping right here to page 173 if you're following in the workbook, and we're going to go to analyze regression linear. What do we get this women legislature stuff out of here? We're trying to predict motor vehicle deaths, car fatals, what it is. So we put that in there. And then we want young population 18 to 24. And then density of the state, population per square mile. We put that in there. That's all we need. We hit OK. Once again, 4 minutes. We're at 4 minutes. All right, I think we can work through this. We got our adjusted R squared of 0.318. That means with using these two independent variables, we can reduce our error in predicting motor vehicle fatalities for 100,000 population by about 32%. That's pretty good, you know, two variables. We look down here, we see the young population of a state has a positive effect on motor vehicle rates. There's a positive sign there. We come across to the T statistic. It's not significant. Okay, remember the t-statistic has to be at about 2 to be significant. 1.96, we're at 1.1, it's not significant. Really, the driving factor is this: population density, negative sign, more densely populated states, like a Rhode Island or New Jersey have, or Florida comes to mind, have a, I think Florida is a high density state, I'm not positive. That results in a reduction in motor vehicle fatalities. It's the T is well above 2, and of course here's probably what most of y'all have been focusing in on. This significance level is way below 0.05. So this has a strong negative and statistically significant effect on motor vehicle fatalities. Now I'm going to hang up here and I'm going to come back for one more on chapter 8. And I'm going to show you something on the board. I think the last time we did it, it didn't come out very well. So Cravens, if you'll pause it or stop it, we'll come back.